Hello again. In part 3, we're going to look at some specific quadratic functions and get a sense of how many roots they have, how many are real roots, and the nice thing about the real roots is we see those x-intercepts right on the graph, and how many imaginary roots we have. And we can make some predictions based on what we see in the graph, and then when we go ahead and solve, we can confirm those predictions. Let's start by looking at the quadratic equation y equals x plus 3 squared plus 4. Notice this is in standard form, so it tells us some key things about our graph, even if we didn't actually have the graph sitting right next to it like we do. So here is what we know just based on this equation. We know that if we examine the a value, that tells us about whether our parabola opens upwards or opens downwards. And so since there is a positive 1 there, we don't see it, it's not written, but it's positive, we know that this parabola is going to open upward. It's going to be shaped like this. We also know that if we examine the h, that tells us our locator point, our vertex, whether it's shifted left or right. And k, the value outside of the parentheses at the end, tells us whether it's shifted up or down. And so what we see here is we see our h value is actually a -3, right? Because it had to be x minus a -3, so that it shows up as a positive. It's the opposite of what we see there. So we know that our graph is shifted to the left 3 and up 4. And in fact, if we examine our graph, that in fact is exactly what we see over here. And so what we want to notice is here's our x-axis. Our parabola doesn't hit the x-axis at all. And so that tells us that we in fact are not going to have any real roots because we don't see any of those x-intercepts. So no x-intercepts, no real roots. But this equation has a degree of 2, which means we will have 2 roots. Therefore, both of those roots must be imaginary. Let's go ahead and solve that equation and see what those 2 roots are and confirm that in fact they are imaginary. So how could we find the x-intercepts if we didn't have the graph, if all we had was the equation? And how could we find specifically what are these imaginary intercepts that we're expecting? So our first step is we know anytime we want to find x-intercepts have a y coordinate of 0. So we start by plugging in 0 for the y value. Then we want to go ahead and solve for x. So our first step is to subtract 4 on each side, and then we get -4 equals x plus 3 all squared. Well, we need to undo that squared, and so the way we'll do that is by taking the square root of both sides of our equation. And so on the left we have the square root of -4. And because I decided to take the square root of both sides, I have to make sure I include both the positive and negative square root. And I'm going to split up -4. I'm going to rewrite it as the product of -1 and 4. And so when I do that, I know that the square root of -1 we represent as I, and the square root of 4 is 2. So on that left-hand side, we have plus or minus 2i. On the right-hand side, we took the square root, right? We took the square root of something squared, and those just undo each other. So that means on the right-hand side, I have x plus 3. So I have plus or minus 2i equals x plus 3. Well, I'm pretty close to having x on a side by itself. I just need to go ahead and subtract 3 from each side. And because of that plus or minus, right, I'm going to go ahead and solve it with the plus or minus in there. But at that point, you could split it into 2 separate equations. And you'll see, we'll come back to that in just a second. So when I subtract 3 on each side, I have -3 plus or minus 2i equals x. And this actually includes both of our roots. with that plus or minus. One of them is plus and one is minus. And you will notice that they are in fact both imaginary, as we were expecting. If I wanted to write them separately, I could. Negative 3 plus 2i is one of our roots, and the other one is negative 3 minus 2i. Right? But we can go ahead and just leave it in this form here. It's a really efficient way to include both of those. And so the way we have this written, negative 3 plus or minus 2i, this type of number that includes both an I, a term with an I in it, and a term that's a real number, that has a name. We call that a complex number. And anytime we write complex numbers, we always write it in the form a plus bi. And so it just means that our term that's a real number, which in this case was negative 3, that goes out front. And then the second term is always our imaginary part that has our I in it. So anytime you have to write a number like this, right, you'll want to go ahead and write it in that a plus bi form. And that comes up in the math notes for this section. That is also printed on the notes you're working on right now. So in summary, we knew this was a parabola that opened upward. We know it was shifted left 3 and up 4 to find our vertex. And with no visible x-intercept, we know it doesn't have any real roots. We were expecting 2 imaginary roots or zeros because this is squared or degree 2. And in fact, when we went ahead and solved, we got these 2 imaginary roots, which we wrote in this a plus bi form that we use for complex numbers. All set.